In this video I'm going to look at further areas. So I'm going to begin with the area of a trapezium. A trapezium is a four-sided shape where obviously it has four sides, but its main property is that it has two sides that are parallel. In order to calculate the area of a trapezium, you've got to have the lengths of those parallel sides. Within a formula and on any formula sheet, those parallel sides are A and B. You're also usually given a perpendicular height. Now that height must be sitting at right angles to the bases, being B or A. Sometimes that height is given outside the trapezium, and of course if the trapezium is a right angle trapezium, then the height is going to look very different because it will be on the width of the actual trapezium. The formula that we use for this, and there is a proof to this, and if you want to know the proof you'll have to watch a different video, but that area is half the height, or height over 2, multiplied by A plus B. And the most important thing is, can you use that formula? So let's just give some numbers. Let's suppose the base is 10 centimetres, this one is 4 centimetres, and the height is 2 centimetres. Let's substitute the values in. So our area is height, which is 2, divided by 2, multiplied by 4 plus 10. 2 divided by 2 is 1, so I'm 1 multiplied by 4 times 10, which is 40, so my area is in centimetres squared, is 40 centimetres squared. What about the kite? Let's look at the kite. So, I'm going to draw a kite. Now, again, this isn't the only formula that you will have seen for a kite. This one I think is the easiest formula, and it really talks about being given the lengths of the diagonals. So with a kite, what you have is these two sides are the same length, and then these two sides are the same length. And one of the properties of the kites is that the diagonals will cut perpendicular to each other. So they should cut at right angles. Now if you're given those lengths of the diagonals, again I'll draw them outside of the kite. Let's call that one X, and this diagonal here, let's call that measurement Y. The area for this kite can be found by a half multiplied by X times Y. That's exactly the same formula as for a rhombus, where you're given the diagonals within the rhombus. So it's just important that you can use that formula. So let's put some measurements in. Let's have this as 10 centimetres. And this one is 4 centimetres for argument's sake. The area then, if this is X and this is Y, is 1/2 of 10 times 4. Let's go 10 times 4. So 1/2 of 40, which is 20 centimetres squared. Let's look at a sector now. A sector is part of a circle, and a sector will have an angle, a fraction of a full circle. That's what the angle is, and a full circle is 360 degrees. So any angle that you've been given, you can put as a fraction of an entire circle when you work its area out. So we usually call the angle theta. And then, of course, this length here, if it's part of a circle, is its radius. And because this is also the same, that is also its radius too. The area of this sector is the angle out of the entire circle, 360 degrees, multiplied by pi r squared, which is the area of any circle. If, for argument's sake, the angle was 60 degrees, let's suppose the angle was 60 degrees and the radius was 3 centimetres. I'm going to write the area in exact form. So I can see that 60 divided by 360 is 1/6. I'll cancel that down. I'll write that in a minute. Multiplied by pi times the radius, so that's 3 squared. 1/6 of 9 pi looks like that, because 3 squared is 9, 9 times pi is 9 pi, and I'm obviously timesing the whole thing by a 6, which is the same as dividing by 6. And I'm dealing with centimetres squared because it's an area. And that's written in exact form. If you needed to work that out, all you do is type in 9 times pi on your calculator and divide the answer by 6. Of course, 9 and 6 can cancel further because both of these numbers are divisible by 3. So I can actually simplify that and write 3 pi upon 2 centimetres squared.